Dear students, welcome to all of you. Now we discuss numerical practical problem 19, Simpson's one-third rule. Problem 19, write a C program to compute the value of the definite integral for the function fx equal to sine 3x into e to the power minus x plus 2p whole divided by square root of 1 plus p x square within the limits of integration 0 degree and 180 degree, correct up to 6 places of decimal by Simpson's one-third rule, taking 19 ordinates where p equal to 4r plus 10 whole divided by 100. Simpson's one-third rule is a closed type 3 points Newton Cotes quadrature formula. Here integration, this numerical integration a to b fx dx, this equal to the approximate value of the integration is plus the error value es, and Simpson one-third rule, simple case, this is equal to h by 3 fx0 plus 4 fx1 plus fx2. Here x0 is the lower limit a and x2 equal to upper limit b, and x1 is the midpoint of a and b, of the points a and b, a plus b by 2, and step length h equal to b minus a by 2. The error term es equal to minus h to the power 5 by 90 f fourth derivative at the point eta, a less than eta less than b. The degree of precision of Simpson's one-third rule is 3. Obviously, es equal to 0 when fx is a polynomial of degree 3 or less. The definition of degree of precision of a quadrature formula is the least positive integer case such that the formula is exact. That is when error term equal to 0 for any polynomial of degree less than equal to k. But there exists a polynomial of degree k plus 1 for which it is not exact, that is es not equal to 0. Geometrically, this is the curve in fx y equal to fx in blue color. This is the curve point. This is the x-axis, horizontal x-axis, the vertical y-axis. This point a, x equal to a, x equal to b, and this point, this dot, is the point a comma fa, and this point is a b comma a b, and this midpoint, this m is midpoint a plus b by 2. So this point on the curve y equal to fx equal to a plus f of a plus b by 2. Now we draw a parabola, this px in red color, this parabola passing through these points, this. So this curve y equal to fx is replaced by a parabola, this red color px, and joining the points, 3 points, this point a fa, uh, a plus b by 2, f a plus b by 2, b a b, and the area of the region bounded by x equal to b, the above parabola, and x-axis represents the approximate value of the integration. Now composite Simpson's one-third rule and divide the range of integration a and b into n sub-intervals by n plus 1 nodes. x0 equal to a, comma x1, comma x2, comma dot dot, comma xn, which is equal to b. The number of sub-intervals n must be even. Apply the simple Simpson's one-third rule in the following n by 2 sub-intervals x0, x2, x2, x4, xn minus 1, xn minus 2, xm, and adding all these we get this, the ISC, C for composite rule, S for Simpson's one-third rule, composite rule, h by 3 fx0 plus 4 fx1 plus fx2 plus h by 3 bracket fx2 plus 4 fx3 plus fx4 bracket, and so on dot dot. So we write compactly, we write this, where h equal to b minus a by n, the step length, and error term esc equal to minus b by b minus a whole to the power 5 180 n to the power 4 f fourth derivative at the point eta, a less than eta less than b. Now This is the C programming. First we define this pi float variable, this constant, which is constant. First we define this 3.1415925, and the function, given function, this is the sine 3x integrand, sine 3x exponential minus x plus 2p whole divided by square root of 1 plus px square. And this float variable a, b, h, p, and x, this one dimensional array, and this x50 sum integer variable in I r. Enter the value of r, last digit of your roll number. Enter the lower limit a in degree, which is equal to 0 degree, and enter the upper limit b in degree, which is 180 degree. Now enter the number of nodes, that is ordinates. Here ordinates equal to 19 ordinates, so n equal to 19. Next, revise this n equal to n minus 1. This n minus 1 actually the number of subintervals. So henceforth this n represents the number of subintervals, and this n not equal to the modulo division by 2 not equal to 0. That means n is not even. N must be even. That is a new n, that is n minus 1, number of subintervals must be even. If this number of subintervals is not even, and this re-enter the odd number of nodes, and so go to the up, this at this point, and go to the up. The number of subintervals is this. This print the number of subintervals here. So here 19 number of ordinates, so number of subintervals here 18. Here redefine a in radian, this pi into a divided by 180, and b equal to pi into b divided by 180, and p equal to 4r plus 10 whole divided by 100, and h step length b minus a into n, and the initial sum equal to 0.0, and print this subinterval x fx fx plus h f of x plus 2h, and the required sum. Now k is the integer variable equal to 1. K equal to 1 represents the new subinterval x0 x2, and when k equal to 2, this represents the new subinterval x2 x4, k equal to 3 x4 x6. Now we first apply this subinterval when k equal to 1 in this first subinterval x0 x2, the new Simpson's 1/3 rule within this interval x0 x2. Here float variable x0 x1 x2. So x0 equal to a plus I equal to 0, so x0 equal to a lower limit, and x1 equal to x0 plus h, and x2 equal to x0 plus 2h. Sum equal to new sum equal to previous sum plus h by 3 fx0 4 into fx1 plus fx2. So new initial sum equal to 0. So this sum value of the integral within the interval x0 to x2, and print this k x0 and so on so on. And next increment k plus plus, that is k equal to 2. When k equal to 2, we go to the next subinterval x2 to x4, and I equal to I plus 2, so I equal to 0 plus 2, that is I equal to 2. So I equal to 2 means this x0 equal to new x0 equal to a plus 2h. Actually this x0 new x0 is x2, and this x1 actually x3, and this x2 actually x4 when I equal to 2. And sum new sum equal to previous sum plus h by 3, this fx0 plus 4 fx1 plus fx2. Actually previous sum means the sum within this interval x0 and x2, this sum plus new sum is this for the interval x2 to x4, and this the improved sum is this, and print this, and print the value of the integration, and correct up to 6 decimal places. Now save, compile and run the program, and this enter the value of r, say 7. Enter the lower limits a in degree 0 degree, enter the upper limit b in degree 180 degree, and number of ordinates according to our problem, which is 19, is odd, so number of subintervals is 18. This is the new subinterval, this new subinterval first, this x0, this 0 x0 and x2, x0 x2, and this x1, this x0 x1 x2, and this the sum is this. And for next new subinterval 2, second subinterval, this x2 x3 and x4, this sum is the previous sum plus this plus the sum for this interval. So actually this column represents the cumulative sum from previous sum. So ultimately we get the number of subintervals 18. Actually we revise this subinterval from x0 to x2, x2 to x4, and so there are 19 new subintervals, and the required sum is 0.144704, correct up to 6 decimal places of decimal. Thank you for watching this video.